Okay, everyone, so let's jump into example 3.6. So what you see here is we have a coplanar force system, and we're going to try to figure out where this resultant vector is. Because remember, if we have the resultant vector, we apply it at the same point, we can consolidate all these four forces into a single force that has the same external reaction on the beam. And all these forces are vertical. And so really we have a pretty easy time of this. All I have to do is choose a point. I'm going to choose A. And the first thing I'm going to do is add up all the forces. So what are the forces? Well, some of the forces, I'm going to make up positive. So I have 10 minus 20 minus 15 minus 25. This is fairly negative, so minus 60. So that'll be equal to negative 50. So R is going to be equal to negative 50. Now the second thing I need to figure out is, well, what is the sum of the moments? Each of these causes a moment. Well, let's look at their line of action. Well, they're all vertical, so line of action doesn't seem to matter too much, except for this first one. Its line of action goes through point A, so it doesn't cause a moment. No moment from it. The rest of them do. So there's some of the moments would be equal to, and let's make sure we do it right, so let's keep on our sign convention properly. So I draw a line and then I turn. Okay. As you can see there, that's clockwise, so that's going to be negative. I draw a line and then I turn. Well, that's going to be positive because that's counterclockwise. And I draw a line all the way over here and I turn. So that's going to be clockwise, so that's negative. So that's a negative moment, this is a positive moment, this one's a negative moment. Okay. So negative, positive, negative. And that does not necessarily depend on what direction they're pointing. It depends on where I am as well as what direction they're pointing. If I did my moment right around this point, it would be completely different. So do not just say, oh, well, it's a negative moment because it's pointing down. That's not the case. That was just because of where I took my moment from. Always, always, always do that draw the line method. Because what you would see is if I did it around this point, I draw a line and I drag it down. Well, guess what? That is now a counterclockwise moment. That's a positive moment. I draw a line, turns down. That one is also positive. Draw a line, that one goes down. That one's negative. So we completely change things based on where I took my moment about. Okay? So do not forget that. Please, 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 please don't forget that. But let's keep on going. So some moments, force times distance. These are all perpendiculars, makes it really easy to me. So 15 times 3, well, that's going to be 45. And like I said before, that's negative. Times 3 plus 6, so that's 9 times 10. Okay, plus 90. Minus 20 times 5 plus 6 plus 3. So that'll be a distance of 14. So 20 times 14. So minus 280. Okay, I add all those together, and what do I get? I get negative 325. Plus 90, so that would be negative 235. And then to solve for that x position, I remember, okay, if I think about it earlier, my sum of the moments has to be equal to the moment caused by this guy. So our r times its perpendicular distance. So negative 235 will be equal to negative 50 times some distance x. If I solve for that, let's see what it comes out to be. It comes out to be 4.7 feet. If your x distance had come out over here, I'll be honest with you that you probably did something wrong. It should be somewhere on the beam. Okay, it should be somewhere on the beam. So you probably thought this was going to be a really difficult problem, but it's not actually that difficult. All you gotta remember is that in the end, you have the same moment because of your resultant force, and you have the same total force. Okay? Be very careful with where you decide to take your moment around, because that will change things. Your final answer will be the same, it's just everything else will, the calculations will be a little bit different. So, thanks for paying attention, and I'll see you all next time. Bye-bye.